Hello, testing 1, 2, 3. Going live at 7:30 if anybody's online. That's for you.
Is it working? What do I do with this?
You can put that on your.
Okay. Hello, everyone. Yeah. Hi. Good evening, everyone, and welcome to this month's ML Tech Talk. My name is Vinay, and I do machine learning here at PicCollage. For those of you who are attending for the first time, we try to have a group of people working or interested in the area of machine learning every month together to share and discuss key topics. And we hope to build a local community by doing this. A few quick notes about the logistics. We have some food and drinks over here, so please feel free to grab something to eat or drink. The washroom is outside the office, so if you want to go to the washroom, please use the outdoor slippers. And last but not the least, quick note about our speakers. We have two amazing speakers tonight. Our first speaker is Anny. She is also a machine learning engineer at PicCollage. And our topic is do anything for image segmentation and recognition models, SAM and REM introduction. So I guess she'll be talking about multimodal applications of multimodal models in image and text. And our next speaker is Pong Ji. He is an associate manager at Makalot Industrial. And his topic is Discover the Art of AI Transformative Image. Unleash the power of generative image modification with Inpainting through ControlNet and image segmentation. So we'll be getting to know a bit about generative AI. So without further ado, let's welcome Anny.
Ooh. So hi everyone, I'm Annie. So today I'm going to introduce to anything for image segmentation and recognition models, which are SEM and REM. So here's today's outline. First, I will introduce what's the difference between image classification and image recognition and image segmentation. And then I will talk more details about segment anything model called SEM. And next is recognize anything model. And the last part is I will talk about some applications by using these two models. So what is image classification? The input will be an image and the output will be the class the input image belongs to. So for example, here we can input image of a dog, and after the image classification model, we can get a class, which is a dog. So what if we have both a cat and a dog in a single image? We cannot just use a simple image classification to do that. So we need image recognition models. The input still an image, and the output can be the semantic labels by recognizing multiple labels. So for example, here we have a dog and a cat, and the output can be dog and cat instead of just one label. So, but by using image recognition model, we can only know what objects are, but we cannot know where the object is. So we need to do some image segmentation. So what is segments? It means we need to divide or partition the image into various parts. So the various part will be segments. And image segmentation model can group the pixels that have similar attributes. So for example, here we have a dog and a cat. After the image segmentation model, we can group the pixels of cat and also the pixels of dog. But it cannot know what the object is. It only can locate the pixel. So here's a quick summary. Image classification can classify what is the image is and only one label. And image recognition, we can do like detect each and every notified object in an image. And image segmentation, we can create pixel-wise mask. So here is more detail about segment anything model called SEM. So the goal is to return a valid segmentation mask given any segment prompt. The prompt is what to segment in the image. It can be for different kinds of types. The first one can be points. And it's just like here, if we want this cat here, we can give the points where included this cat. So we can have these two green dots. And we can also include the boxes surrounding by the cat and also the mask, and also the last one is the text. So we can just simply input cat with black ears. And the output will be a valid mask. What is the valid mask means? It means that if we input an ambiguous prompt, it will output at least one reasonable mask. So ambiguous means, like for example, here we have this green input point, and the mask might be like a whole person or just the bag include this green point, or just this pocket including this green point. So the green point is the ambiguous prompt. So either of these three masks output is a valid mask. So here is the model concept. There are three main concepts. The first one is flexible prompts. As I just said, we can input for different kinds of prompts, and it's real time. It can process fast. And the last thing is ambiguity aware. Just like I said, it can detect ambiguous prompts. And the structure actually is very simple. So we have three kinds of three parts. The first one is image encoder. So the input is an image, and the structure is a vision transformer. The output will be just the image embedding, and the other part is a prompt encoder. So you have two different kinds of structure. The first is for sparse. Sparse it means like points, boxes, and it will be like learned embeddings. And the text is very simple, just input into the clip, we can get a text embedding. And for the mask part, it just builds some convolution layers to get the mask embeddings. And the last part is very simple, just a decoder like transformer decoder. And then output will be a valid mask. So here is the whole pipeline. We can input image and get image embedding, and we can input the different kind of prompt like mask and points, box, and text. And then after we have the decoder, we can have different segments with the score. So by using the score, we can filter some bad segments, or we can rank the scores. So as you can see, here is the result of. It can be get very detailed information, like it can get like 100 to 200 masks. So it's very actually it's a state-of-the-art model in image segmentations. Yeah. And the other model is the recognize anything model, which is also called RAM. And it's a strong model for multi-label image recognition. I think the most powerful part is that it can demonstrate the zero-shot ability to recognize any common category and still has a very high accuracy. So this means it can know unseen text, even it's not trained, it still can recognize the text is unseen the text. So the model can be very simple, just like them actually. And it is very strong in general, and it's very reproducible and affordable because the model structure is very simple. So its process time is very quick, fast, and also it's very flexible and versatile. So the structure actually is just also a three part. The first part is a transformer to get the image embedding, and for the tag list. So the tag list is you can define by yourself. It didn't need to be the trend text. It can be anything tag you want to recognize. So it's very powerful. And the reason is that it uses clip to get embedding. So clip can get the information about this tag. That's why it can do zero shot. And the last part is the decoder. And after that, we can get an end text of this image. So here is some comparison between other models. So as you can see here, we have the stem that has a high accuracy in localizations, but it cannot do recognition of its labels. But RAM can do the recognition, but it cannot actually locate where the object is. And for other models that can do recognition, actually the RAM has high accuracy than others. So for example here, RAM can detect almost everything, but other models like Flip might missing something like lamp or blanket. So I think RAM is actually, you can try for tagging. It's very useful. So here is our applications. So usually we do cutout. We simply just remove the background and we save the object we want. But sometimes we will have some problem. When we do the segment cutout, we might have some parts that is missing. The model might misleading that it doesn't know it's the object. And we can do like manually to add it back. But I think the powerful part of them is that we can add things based on the segments. So it's like this. We can add very quickly and with sharp lines in the edges. So the same, we can erase the object we don't want and with clean edges, and it's very fast. So I think this is very useful for user. And then if can show other sample. So if in the old time, we just need to do like this. And it's very time consuming and we cannot get clean edges. So by using them, we can like add things and erase things by segments. And another example is that if we have something like this, sorry, the image has very detail and has a small part of the object. So we can do like this to add the object back, and it's very has clean edges of each object. Yeah, so this is one of the application for them. And here is the application for RAM. So with RAM, we can get the text of the photo. So this text can be seen as the context. By using this context, we can do a lot of things. For example, we can do like template suggestions for the photos. So we input a photo with like a dog with a woman, and after we use RAM on it, we can get the text like dog, hug, pat, kiss, smile, and part. And after we get this text, we can input into our template search algorithm, and it can know, oh, this picture has these things, so we can recognize this text and recommend this template related to these photos. And here's another scenario. We want to use text to generate the caption for the image. So the same, we can get the text of this image, and we can input into the OpenAI API and do some prompt engineering. And then we can get different kind of caption, like very short title, like for love, or a slightly long description, a smiling cloud with my pet, or some simply description of this photo. You are on a cozy date with your furry Valentine. Yeah. So with RAM, actually can do a lot of application because it can detect things, detect the content of the photo with high accuracy. So yeah, this is today's presentation. Thank you.
I think we'll have a bit of breakout, but we'll also have some Q&A. I won't put you on the spot questions right now, but maybe have a few minutes together, talk about what you've just seen, and then come up with a couple of questions, and then I think Annie's happy to answer any of them. Okay? So yeah, chat for a couple of minutes, and then we'll come back. Okay? Thank you. Okay, good. So yeah, did anybody come up with any questions? Yes, one at the back. Want to grab the microphone or you can yeah, yeah, go on. Don't be shy.
Thanks for your introduction. I have a question. Have you tried to use GPT for vision and then compare the result with them?
Sorry,
Yeah, so like this week there's a
GPT.
GPT-4 with vision. So the OpenAI GPT-4.
Yeah.
So they have a capability with vision.
Actually, we didn't use the vision part. We just
Okay.
input the text.
You say you don't try the model.
We use because for now it just only supports the text instead of the image part. So we input the text of the image instead of
So you say you haven't shown the GPT-4 vision.
Thank you. Okay, thank you. Any other questions? Going over. Yes, we've got one. Great, awesome. Thanks very much.
Thanks for So for the extraction, for the RAM model, like how do you guys, like for example, let's say there's a picture of a human or something, and then it extracts like monkey or something, and then it says let's do something with monkeys. Do you guys like get some radars to prevent the customers from getting angry?
Do you mean we have some define our text or something?
Like, I mean, I'm not sure how exactly automated process of the recognition anything model is, but like when you use it for extracting text from images, right?
Yeah.
Like maybe there must be the model is biased or misclassified.
Yeah.
Right. So might lead to some
Bad
kind of
result.
errors or
Yeah.
bad results or unhappy customers or whatever.
Yeah.
So do you guys do anything specific in that?
Yeah, actually we define our own text that especially occurs a lot in our users' photos so that we can prevent like other things happen. And then we have some manually ratings and evaluation for our results. So we will fine tune the model's result and text to avoid these things. Yeah.
Thank you.
Awesome. Yes, you're popular. We've got another one. Go for it.
Thank you for your sharing. I was curious about a video that originally the photo the model shows there are some people in the photo, but the dirt was not an object. And then you click the photo and the dirt or other objects will be detected. I was curious about how does the model influence the game, a part of picture or a full picture?
Do you mean if we have a whole video and we have a lot of frames?
Yeah.
And how do we do like the caption things? Actually, we have another model that can detect the highlight part. So we can highlight some important clip. We can call that we can divide it into small different kind of videos that is very important. And we will just get the first frame. So we will not get each second of the frame so that it can be more accurate, I think. Because skirt, it might be not important for the highlight model. Yeah.
I mean, you just showed that originally we didn't detect, for example, there are 5 people in the picture and the model can detect 4 people. And the mouse click
Okay. Yeah. Yeah.
Okay, good. Right. I hope you're having some interesting chats, meeting new people. So yeah, we're going to move on to the second part of today's ML Tech Talks. Also, by the way, I did mention to you earlier, if you want to talk at this thing in the future, feel free. It's not super exclusive, not VIP. We're just welcoming people to come and talk here. Although today we do have a VIP coming to talk to us. So yeah, I think I'll pass it to you, and yeah, the floor is yours. Thank you.
Thank you. Hello, everyone. I'm Paul. Thank you. And today I'm going to present about it, discovering the art of AI transformative image. And here, let's talk something about me. Oh, sorry. Actually, I'm from Thailand, and here is my full name, so it's quite long. So I prefer to call me Paul. And I'm an AI engineer lead team in the Makalot company. And my topic of interest is generative AI in both image and text. Also, for the 3D AR, VR technology. And the third one is the IoT and data analysis. And let's briefly know about my company. My company, Makalot, is not a Mekalot, but we also make a lot of courses, textile, and here is our product. Our main product line is sleepwear, activewear or sportwear, and also ready to wear. And here is some of our customers. I think some of you might saw one of this logo, and maybe one of you might wear this kind of logo here today. And actually, apart from our main product, currently we also have the innovative product that we researching on. It is a smart apparel, like the smart sensor in the process to detect the body condition or to capture the motion. And also, another topic is, the main topic is digital product creation, or the DPC, or we can say it's a 3D process. And actually, from the 3D process, it comes from when we have the traditional garment industry, we need to have to produce the clothes by the customer requirement. When we get the requirement, we need to make a sample and send it to the customer, and maybe have several times of the review with code take a lot of time, the pattern cost, material cost, and also the delivery cost. That's why we would like to make this one for the digital life to make it more easier to develop and to contract with the customer. So we have the 3D and also there are some problem about the 3D, which is because of the 3D model is quite unrealistic and it takes quite a lot of time to create or to modify. So we would like to try to use some AI generation to quickly modify the 3D into the 2D model with the several point of view such as the front, side, and back. For customers for the reference. And we're researching on several kind of solution in the market, such as the Stable Diffusion, Midjourney, or the DALL-E from the OpenAI. Still, in every solution, they have some kind of the same problem. Like when we put the image into the website, into the system platform directly, we found that the result is looks similar but not the same. Such as in this one, there lost a lot of detail, such as the pocket here, and also this one, the color and the pattern here is very different. So this one is NG work, and we couldn't present this one to the customer. Sorry. So that's why we take a deep look into the one of the solution, which is a Stable Diffusion one, and we found that they have two of the components that we could use it. Like the first one is the ControlNet, and the second one is the Segmentation anything, like the Anny presented in the previous one. And for the ControlNet, first I will explain about the Stable Diffusion. Actually, this is how Stable Diffusion works, but it's quite complicated. So I will try to summarize it. Actually, this is the structure of the Stable Diffusion. We will input the image into the encoder and send it into the forward filter in the latent space, and combining with the prompt and image. And after that, we will send back into the reverse diffusion step. And after that, we will send to the decoder and we will get the image. And when we combining with the ControlNet, which is a neural network that can control the Stable Diffusion model by adding the extra condition into it. As we saw in this photo, the below one, we will found that actually ControlNet is like a pre-processed model that we can put the image into the model and it will change into the edge or the other geometry. And after that, we will put the ControlNet in the front and back of the network. So they will control how the image will be look like. There are several models for the ControlNet, like sketch, normal map, depth map, candy edge, MLAD, and human force. I will select some of this one and explain about how it works. First one is the candy model. Actually, candy model is one of the image processing model that can use for edge detection. They will compose of 5 steps. First, when we input the image into the model, it will pass the image into the Gaussian to calculate the edge of the model, and after that we will send the Gaussian to the gradient calculation and send it to directional non-maximal suppression. After that, we will calculate the threshold and use the hysteresis threshold. When we solve about the threshold, we will know that it can adjust the upper and below. So we can put it in here. They can adjust the threshold for the weak, for the normal one, or for the strong one. So we can detect more detail or less detail. Like this image, original one, we can change it into the candy edge. And after candy edge, when we send it into the Stable Diffusion ControlNet, we will get quite a similar result. We will get the bird, the wood here, but there are something different like the color and the material here, because the candy will recognize the edge, but they didn't recognize the feature like the color here. And when we test it with the the human one. Such as this photo is quite a simple process. We can find that actually it's quite precise. Like this one, strong one also precise, and normal threshold also precise, and also for the weak threshold also precise. However, if we put a more detail like this kind of the image, this one they will have the logo here, and also they will have the pouch here. When we put the image into the network, we found that the logo here is gone. The pocket here is also gone. Even the normal model, everything is gone. This is due to they're quite complicated. The edge couldn't detect much this kind of the detail. So actually, it's good for the simple image, but it's not good for the complex one. Another model that can use is a line art model. The line art model is rendering the outline of the image and converting it into the art. There are several pre-processed techniques for the line art model, like the animate, the realistic, and the corset one. When we for the original one and change it into the line art, they will change the structure of the image, but reserve the basic structure. And when we apply to the sample image, we found that actually, apart from the pose and process, actually there are several things that different, such as the shoe, also the bending head, the chair here, and also even this one, they change it completely. It might not suitable for the to transform the image into the real one, but it's good for creation, the animation or the cartoon style. There are another model like MLAD or mobile line segment detection. This one is suitable for the building. It will detect the line, so it can change from the. It can detect the line, and we can use it with a stable width diffusion to create another such layout of the building and also layout of the street. So for the ControlNet, here there are more model that we can use, but here is my present. And after that, I will talk about the segmentation anything of SAM model. Actually, it's like the Anny present before. Actually, it's a model for detect the segmentation of the image by using the prompt or using the bounding box or using the point. Here is the main structure of the SAM. From we input the image into this encoder, the image will embedded into this lightweight decoder. At the same time, we can send the point, the box or the text into this prompt encoder to detect which segment that we need. So we can use several inputs such as point or use a box or use a text for get our target. Still, there have one issue, which is we need to have some identifier to make this SAM more accurate or point the thing that we need to use for segment. So we need a grounding deno to generate the bounding box for it. Actually, the grounding deno is like the code for us for detect the segment more precise. And for the grounding deno structure, they will separate into two parts, which is the image and the text extraction. For the text, they will use a BART model, and image we use a Swin model. After the encode text is into the encoder, we will send it into the feature enhancer, and after that, the feature will change. Will be using in the language guiding query selection to cross-reference the data, and after that, the query will fed into the decoder and predict the box. After we get the box, they will send it to the SAM, and it will render the result for us. For the example, like the image before, when we use the crowding deno, they will change into this one. This one, then we have the bounding box and the stamp. Then we have the segmentation here, which we can get the mask image from this one. After we get the mask image, we can use a stable diffusion to generate image to the new one. We'll see that actually it is the same image from the mask, but for the face, we can change it into anything we would like to change to. Like this one, the more difficult image one. After we change it, we can change it into many kind of the human, such as the Taiwanese, American, or Indian. Actually, we also can change it into women, or this one change it into man. There are another case such as if we would like to change the subject which isn't human, such as the cat. When we just need to change the prompt, such as when we change it into cat or even the bench, so it can detect the bench or the cat, and we mask it and change it into another one, such as the dog, the rat, or this one change the bench here to the wood or the metal. So actually, it can detect anything, and we can use this kind of feature to change or create another image. Or even for the cartoon image here, we also can detect any part that we want, and after that we can get a mask on the image here, and we can change it into another thing that we would like to change it to. Or we can use it differently, such as we can detect a subject. We already get a subject, we would like to reserve the subject and change the object. And change the background, we also can do something like this. And for the conclusion, actually each of ControlNet provide a different kind of the feature. We need to know which ControlNet can have which kind of the function in order to use it correctly. And also edge detection actually is good for preserve the sample cross style, but it's less effective for the complex texture. And another thing is that SAM can accurately detect and extract element. However, when we get the mask will be fixed. So that's why for the future work, I think we need to combine the ControlNet and SAM in order to get the mask. After that, using the open post or another ControlNet to change the post of the human without changing the structure of the post. Another thing is we would like to try if we could use a 3D model to use the imagination and use a network to change the 2D into 3D model without change the detail of the process. Thank you.
So I think we'll do it again. Have a quick talk to the person next to you about £1 is just gone over there, and then we'll come back to questions in a couple of minutes, and then we'll break for final happy hour and then goodbye. So yeah, chat, go for it. Thank you very much.
Thank you. Should I close this one or put it? Okay.
solve the problem by we have an image. I took a photo of these, let's say, and I just erased your head and I put it in a different head. It's just that. So it's like this. And now the only parts of the generating part. It's like this part of us maybe that has and it got rid of a lot of this. Which I wonder how
Okay, I think I'll pick on this first.
Okay.
Right, I think we've got a couple of questions. So yeah, Vinay is going to ask a question first.
Yeah, I wanted to ask you, how did you generate the image from the output mask? So once you get the mask from segmentation model,
How to get the mask?
how do you feed the map? Like, what is the input to the segmentation model, which creates the output which you showed us? Like, is it ControlNet or is this outpainting, inpainting?
You mean from the segmentation anything?
Yeah.
Actually, I put, I just put this, like this one, I put this image. Oh, sorry.
Sorry.
I just put the original image into segmentation anything.
So this image on the left.
Yeah.
And the mask.
With the prompt and
Uh-huh.
and it will generate the mask into for me.
Yeah. So how do you use the mask and the image to generate these images?
Actually, I use the API to
Uh-huh.
after I get the result from the mask and image, I just use the API to render the mask and send it back into the imprinted model. Yeah, imprinted.
Also, it's inpainting.
Yeah, imprinted.
This is inpainting with the prompt.
Yeah.
Oh, okay, cool. Thanks.
Oh, thank you.
Cool. Thank you. And then I think no, you nearly had a question. Okay. Any other questions? Yes, we've got one over there. Brilliant.
Sorry, so when you're using the mask and then in the final image,
Yeah.
because you're just taking a mask of it,
Yes.
the example that you used of like changing it to a woman, for example, the way that the clothing would sit, does that change at all because you're just using the mask, or would the clothing sit the same way on the model?
Oh, yes. Actually, because of it's an imprinted,
Yeah.
so it's a mask with the imprinted. So it will reserve the structure of the corset. So it's like using a ControlNet plus the segmentation.
Okay.
Yeah.
Okay. Any more? Or any more? If not, okay.
Follow up.
Yes. Okay, cool.
So you change then the mask to something bigger, right? Like instead of only face, maybe also the body, then.
Yeah. Actually, we can. It depends on our prompt that we want to use the mask. Like this one, we can put the mask only tuxedo or only some part of it or only the head. So it depends on our choice which one we want to use it as a mask.
Okay, thanks.
Oh, thank you.
Good.
Thank you very much for the questions, everyone. In that case, I think final round of applause for Pound. And I think we can just go to happy hour, just chat, get to meet other people and talk about the talks. Thank you very much. Okay.
Right. Thank you.
So wouldn't really.
Curious to use.
Yes.
Are you actually using this for changing the training model to clothes?
Yes, actually, because of this, I just use this one from the online because
For the what online?
I took the photo from